Hello dear students, myself Dr. Varsha from the Department of Pharmacy, School of Health Sciences, Sushant University, and I am here to give a lecture on rheological aspects in pharmaceutical formulations development. For example, gels, ointments, pastes, okay, and every Hello dear students, myself Dr. Varsha from the Department of Pharmacy, School of Health Sciences, Sushant University, and I am here to give a lecture on rheological aspects in pharmaceutical formulations development. Today we are going to learn about the rheological properties or the flow properties of the liquids, viscosity of the liquids, types of flows of liquids with Newtonian, non-Newtonian, plastic, pseudoplastic, dilatant flows, Thixotropic properties of the liquids, and further we are going to learn about the methods which can use to determine the flow property of the liquids. That is what we are going to learn in today's lecture. So how we define rheology? The definition of rheology is it is a science that concerns with the flow of liquid and the deformation of the solids under stress. What is stress? Stress is the pressure we are applying on any liquid to make it flow. Okay, the study of flow properties of liquids is important for manufacturing of dosage forms, simple liquid gels, ointments, creams and pastes. You all know your day will start with the pharmaceutical cosmetic formulations. For example, gels, ointments, pastes, okay, and every formulation have a different consistency. One can be very viscous, one can be liquid in form. Okay, so that depends on the rheological property of that formulation. What is the law of rheology? What is the law of rheology is Newton's law. So the flow property of the liquids depends on the Newton's law. Newton's law states that the shear stress between adjacent fluid layers is proportional to the velocity gradients between the two layers. Okay, the ratio of shear stress to shear rate is a constant for given temperature and pressure and is defined as viscosity or coefficient of viscosity. So what is rheology and what is viscosity? Rheology is the study of flow properties of the liquids wherever viscosity is the property of any liquid to flow. Okay. Then what is the formula of viscosity is Fg or F is equal to neta G, where F is shear force we are applying on any liquid to move and G is the rate of shear. Viscosity, if I will define the viscosity to you, then viscosity is defined as the resistance in the flow of liquid, which means a liquid have its property to resist the flow. For example, if we take water and honey, then honey have higher resistance than the water to flow because honey is very thick consistency and water have low consistency. That is depends on the viscosity property of that liquid. As if I define it as a definition of viscosity, then it is the internal friction between two layers of liquids which resists the flow of liquid. Now what is the unit of viscosity is poise and it is denoted by neta. Which factors can affect the viscosity then? If a water is flowing through the pipe, then you can assume the flow of that liquid can be affected by the intrinsic factors or the extrinsic factors. In intrinsic factors, the molecular sizes, types of molecules, means shape of molecule, it can be rough or it can be smooth. If the particle shape is smoother, then the flow of that liquid will be smooth. And if the rough surface is there of particles, then the viscosity of that liquid would be higher. Next, intermolecular forces. Intermolecular forces means the forces between the two particles present in that liquid. That is intermolecular forces. If there is repulsive forces between the particles, then the flow of that liquid would be higher. And if the forces between the molecules are attractive, then the viscosity of that liquid would be low. Okay, then after that there can be extrinsic factors which can affect the flow property of the liquid, that is temperature or pressure. If we can take example that if we heat the solution, then the viscous product or viscous solution will start to flow smoothly. So temperature, if we increase the temperature, that will also affect the viscosity of the sample. Depending on the viscosity of the liquid, we can differentiate the substances. For example, water have low viscosity because there is lesser intermolecular forces between the particles. Then the olive oil, which is medium viscous because the intermolecular forces are medium, and the honey, which is highly viscous because the intermolecular forces are very higher. Then, depending on the flow property of the liquid, we can differentiate them as Newtonian flow or non-Newtonian flow. These are depending on the following of law of Newton's. If the liquid is following Newton's law, then it is Newtonian flow, and if it is not following the Newtonian law, then it is non-Newtonian flow. What is Newtonian flow? Is following the Newton's law. The liquid which do not need any external force to flow is the Newtonian flow. In this, we apply the shear stress, means the pressure on the liquid to make it flow, and which will flow in a linear line as shown in graph. Okay, if we apply this, if we are applying shearing stress, and with respect to rate of shear, the flow of the liquid would be linear. For example, water. If we pour water from a bottle to a glass, then the flow would be very smooth. That is Newtonian flow. What is non-Newtonian flow then? If we apply force on the liquid, then it resists. It resists more, and it behaves like an elastic material. What is elastic? Elastic is like rubber. If we push it or we apply force to expand it, and if we remove the force, it will again becomes the same as the previous or retain its shape as the previous. That is elasticity. So non-Newtonian flow are those substances which fail to follow Newton's law, that is liquid and solid, heterogeneous dispersions such as colloidal solutions, suspensions, liquids, paste, gel, etc. Then, depending on non-Newtonian flow, there are a classification which is time independent and time dependent. In time independent, there are three types of flows. First one is plastic flow, pseudoplastic flow, and the dilatant flow. So these are the rheograms which are representing the types of flows with respect to the applied shear stress. If we apply the shear stress, it will flow smoothly. It is Newtonian flow. Okay, and if we apply force and it resists or showing elasticity, means we apply some extent of force to the liquid, and if we remove it, then the liquid will come back to its previous stage. But if we extend our force, if we apply more force, then the liquid will start to flow. That is plastic flow. And the force up to which extent we apply and the liquid starts to flow, that point is known as yield value. Then pseudoplastic flow. Pseudoplastic means, pseudo means mimicking or false. That means it mimics the plastic flow, but it is not plastic flow. Okay, that is pseudo-plastic flow, in which we apply the force and it will not resist. It will not show any kind of elastic behavior. So it will start from the origin, and if we apply the shear stress, it will starts to move. That is pseudoplastic behavior. For example, if we mix tragacanth in water, okay, then that is pseudoplastic behavior of that liquid. Then next one is dilatant flow. Dilatant flow maximum time showed by the higher consistent liquids. In this, the graph will have some not linear, starts from origin, but when we apply the force, it will start moving or flowing after some extra forces applied. Okay, that is dilatant flow. For example, polymer mixes or the suspensions with higher solid content, that shows dilatant flow. Next one is thixotropy, which is a time dependent flow of any liquid. Thixotropy, it means in this a suspension or any solution which have higher solid content, and if we put it aside and it will, if I will shake that, this state of matter or the liquid flow will change. Okay, it shows sol gel behavior, in which if we shake the bottle or apply the shear rate or shear stress on the liquid, then it will convert into the solution, and if I will set aside the solution to rest, then it will again convert into the gel. That is thixotropy. It is also defined as isothermal or comparatively slow recovery on standing of material of a consistency lost through shearing. Okay, if we apply force on that liquid, then the consistency of that liquid would change from gel to sol, and then sol to again gel. That is thixotropy. Then thixotropy, which is a time dependent property of any liquid to flow. In this, we apply force on any liquid, then it will change from gel to solution, and then solution to again gel. That is known as thixotropy behavior of any liquid. A liquid have different properties when it stands in rest and when force is applied on that. Okay, if we put a suspension, you can take suspension, kind of suspensions are there available which have property and which are mentioned on their label that shake well before use. So it will convert their flow property from rest position to the applying force condition. Okay, that converts the gel into solution and then again to gel state of the liquid. That is thixotropy. What is the application of thixotropy in pharmaceutical drug development? So for formulation of hydrogels, ointments, suspension, emulsions, thixotropy is a very important property, because when we push out the gel from any tube or any container, then we apply force on that and the gel will come out from the container. That is because of their rheological properties and the thixotropical properties. Then determination of viscosity, how we can determine the viscosity of any substance. There are two type of methods which can use to determine the viscosity. First one is single point and the multiple point, second one. In single point, we apply only one shear stress. But in multiple points, several rates of shear are applied. There are examples for single point viscometers, Oswald viscometer, and in multiple point there are cup and bob, cup and plate. Okay, so first single point viscometers are generally used for the Newtonian fluids, and the multiple point viscometers are used to determine viscosity of the non-Newtonian fluids. First instrument we are discussing about Oswald Viscometer, which is also known as capillary Viscometer. This is used for Newtonian fluids. For example, water, or we can say milk, that kind of solutions we are used in this apparatus. Then falling sphere viscometer. In this we use a sphere in a thermostable container, and it is used to determine the viscosity of the Newtonian and non-Newtonian both fluids. Next one is cup and bob viscometer. In this, the principle is depends on the RPM or the rotational speed of the knob, where we place the liquid on the flat surface, and the 100 RPM we rotate the knob, and the rheology of the liquid we can determine. These are multiple point instruments in which we are applying multiple shear rates. Then cone and plate viscometer, in which we plate gel or our substance, liquid substance on the plate, and the upper knob will fall down on that plate, and the rheology of the liquid we can determine by rotating oscillation method. What is then why we are discussing all about the rheology? What is the importance of rheology in our pharmaceutical industry? So it is wide application in manufacturing of dosage forms and handling of drugs for administrations. Formulation of emulsions and suspensions, posaries or tablet coatings are also depends on the rheological properties of the chemicals we are using. Then formulation of medical and cosmetic creams, paste, that kind of formulations are also depends on the rheological properties of the chemicals we are using. Then fluidity of the solutions, for example cough syrups we are using, then if the consistency of cough syrup is not efficient or not justified, then it is hard for the patient to take that cough syrup through the neck. So rheological properties are very important to develop any kind of pharmaceutical product. So from today's lecture we have learned about the rheological property. What is rheology? Flow property of the liquid, then the viscosity of the liquid, the factors which can affect the viscosity, then the types of rheological behaviors, plastic behavior, pseudoplastic behavior, dilatant behavior, different kind of fluids, for example water and the olive oil or the honey, the different kind of formulations, emulsion, suspension or the polymer mixes which show different kind of rheological properties. Then we come to the methods which can use to determine the rheology of the liquids. Then this is and the importance of the rheological properties or the rheological studies in the formulation development in pharmaceutical industry. That is the conclusion of the today's lecture. That is the importance of the rheology in our pharmacy. Thank you.